All right, and so here we have an example 3 from the book. And what we're going to do is just go ahead and graph this function and then determine the domain and range. So here you notice I tried to use one that's already created. I'm going to just do this for now on when I can, as it's much easier when you don't have a ruler. So the front of a camping tent can be modeled by the function y equals to negative 1.4 times the quantity absolute value x minus 2.5 plus 3.5, where x and y are measured in feet and the x-axis represents the ground. So this should look like the front of a camping tent. And since we're using the absolute value, we know it's going to have a V-shaped look. Now this negative lets us know that it opens downward. So it's going to look something like that versus something like this. All right, so let's go ahead and graph this function. I'm going to use the shortcut methods that I've been showing you. So first, we want to get our vertex. Our vertex is going to be positive 2.5. Remember, switch that sign. So positive 2.5, and then positive 3.5. So we go to 2.5, which is here, and 3.5, which is up here, and that's our vertex. All right, we can use either our understanding of the a. Now that might be a little bit challenging here with the 1.4. So there's another way to figure that one out. And we can actually graph the function by using our understanding of points. So we can do one of two ways. And the easiest of those one or two ways is just to see where it touches on the x-axis. So let's go ahead and use 0. That's the easiest one. We could use it like a table. So we have negative 1.4 times the quantity 0 subtract 2.5 plus 3.5. Now you could use the slope by just saying, down 1.4 on the left and down 1.4 on the right. Remember, we could split it up into 3 different equations. Or you could just use the table as I'm doing here. So we have y equals to negative 1.4 times the quantity, the absolute value of negative 2.5, which is just 2.5 basically, right? When you take the absolute value, plus 3.5. All right, so we have y is equal to, and we can multiply that out. We have 1.4 negative times 2.5, and that actually gives you negative 3.5 plus 3.5, and so y would be equal to 0. So at x equals 0, y equals 0, that's actually the point. And so we could just erase the circle, and we can just now connect the two because we know that they're going to touch. So that's our first one. And then we can reflect, right? Because it's symmetric, we could just reflect that point over. And since it's 2.5, that means it would be at 5. So there'd be a point right there. And done. We just connect those two. And there we have it. It actually looks like a tent. All right, so we've done part A. And now we can do part B. It says interpret the domain and range of the function in the given context. All right, so remember, domain are your x values. We did that under the functions section. So let's write out what our domain would be. Our domain is going to be 0 is the limit, and 5 is the other limit, right? From here to here. And I wrote x, so let's change that to a 5. So that's our domain. To find the range, you can either substitute those values in to find the range, or you could just look on the graph. And you can see that the range goes no higher than 3.5 and no lower than 0. And so remember, our x's here represent, it was already given to you, x-axis represents the ground, right? And x and y are measured in feet. So that's horizontal and vertical. So 3.5 is the highest you can go for the range, and the lowest you can go for the range is 0. So that means, in terms of the given context, the tallest, the height of the tent, height of tent is 5 feet, and the width of the tent is also 5 feet, right? 2.5 is 5 feet. And I said also 5 feet. That should have said 3.5. I built my way up to it and still said 5. So that's 3.5 feet, right, is the height as I was showing here. So the height of the tent is 3.5 feet and 5 feet wide. So 5 foot wide tent, 3.5 feet in height. Okay, the last one that we have here, an example again from example 4. While playing pool, you're trying to shoot the 8 ball into the corner pocket, as shown. Imagine that the coordinate point is placed over the pool table. The 8 ball is at 5, 4. So if you're not sure what the 8 ball is, it's the black ball right here. Oops. The black ball that's right here, right? That's our 8 ball. And it's saying that that point there is x equals to 5, so halfway, and 5 over 4, which is about 1 1/4. You're aiming for the 10, 5, right? Because the table is 10 feet long, then this represents 10. And since it's 5 foot wide, this is going to represent the unit 5. So this is the point 10, 5. You're going to bank the ball off at 6, 0. So right here, where the ball's going to hit, that's the point 6, 0. All right, so now that we have a basic idea of this equation, we're going to write an equation for the path of the ball. Remember, the standard form of this y equals to a times the quantity x minus h plus k, where h and k are the vertex. So where's the vertex in this graph? Well, this is our vertex, 6 and 0. So that's going to be y equals to something, whereas that's our a value, x minus 6, that's the h value, plus k, which is 0. So you technically don't need that 0, and so I'll just write it here so you can see it. And now we need to determine what the a value is. Okay, so we have the equation. If we simplify this, y is equal to the quantity x minus 6, right? We don't know what the a is. So we can substitute with any of these points in there to figure out what a is. Because we're aiming for 10, 5, we don't want to put that in. We don't want to put 6, 0 in either. So we're going to use the 5, 4 one. And so let's go ahead and substitute that in. I'll solve it over here on the side. We're going to have our y is 5 over 4 is equal to a, which we're looking for. The quantity x is 5, right? 5 minus 6, no k. So that's 5 over 4 is equal to a. 5 minus 6 is -1. And absolute value of -1 is just 1. So 5 over 4 is equal to a. Alright, so we can rewrite this as y is equal to 5 over 4 x subtract 6. That's our function or equation of the path of the ball. So they want to know, do you make the shot? So let's go ahead and substitute those in to see. Right? If we substitute the value 10, 5 in there and we get the identity, remember the identity is like 2 equals 2 or 1 equals 1, then we know that we have made the shot. So we can substitute this value into our equation, y equals to 5 over 4 quantity x subtract 6. So our y value is 5, we have 5 over 4, our x is 10, subtract 6. So that's going to be 5 is equal to 5 over 4. 10 subtract 6 is 4. Absolute value of 4 is 4. So you don't really need the absolute value signs anymore. We could just take those out. And remember, you're multiplying. So you're actually saying 5 over 4 times 4. Those 4's cancel, and you do get the identity. So yes, you will make the shot. So I'll just put yes, but yes, you will make the shot.